So let's look at this one. Magnetic field exerts a force on a moving charge given a charge Q columns moving with velocity v measured in meter per second in a magnetic field B measured in Teslas. The force F on the charge is given by this, okay? Where F is measured in newtons. So a charge of 1.6 multiplied by 10 to the power negative 19 columns is moving with the speed of 3 times 10 in the direction vector of this. Okay, great. So this case here, so if it's in this direction, v will just be 3 times, this is the magnitude, the speed is the magnitude, right? So this is modulus v, okay, the magnitude multiplied by the unit vector of this guy here. So let me say this guy here would be, is actually just this direction, right? So maybe we just let a equals to 1. So v will just be the magnitude multiplied by a unit vector. Okay, so 1 unit length, because it's in this direction, so this is 3 times 10 to the power 6. Then there will be 221 over square root 2 square plus 2 square plus 1 square. Actually, a unit vector is also equals to v unit vector because they are parallel to each other. Okay, this could be v unit vector. If you don't write this case there, you can just write it as such. As in, you don't want to let a be this straight up can just be v unit vector. Okay, so but anyway, I'll just go put this here. We just use the application of unit vector because 1 unit corresponds to a. Then if you have 3 times 10 to the power 6 units, then you will just multiply it by 3 times 10 to the power 6 units. Okay, that's about it. Just multiply by this. Okay, that's about it. So this is our v. The charge is moving in a region where the magnetic field is this. Okay, this is the magnetic field. So that is it. Find the force v acting on the magnitude of the force. Okay, that's pretty okay. So once done, what I'm going to do is 4 plus 4 plus 1. That will be 3, 9, square root 9. So v is equals to 10 to the power 6. Okay, maybe just write this down. Two to 1, 6, 2 to 1. So it's in this case here, what we get is for F is equals to, this is a charge, so Q is just a scalar multiple here, then V, which is this guy here, 2 to 1 cross with 4 2 minus 3. Okay, that's it. This is the force, right? We want to find acting on charge and the magnitude of this force. Find the force. So this is the force here. So we just need to do cross product. Maybe I'll just take this multiplied by 6. You just cross these two will be enough. Okay, so that's it. This case here, maybe I write it down nicely. F is equals to Q V cross B. Okay, so then you're gonna just cross this both here. This will be 1.6 times 10. Crossing these two will be negative. Cross product, minus 6 minus 2. Negative 6 minus 4. 4 minus 8. There will be so I'm gonna factorize the 2 out. Negative 4, 5, negative 2. (3.2) times 10 to the minus 13 minus 4, 5, minus 2. Okay, great. So that's our force. So the force, find the force F acting on the charge. So hence this is a force F. Okay. Yeah. So the direction Or you want the magnitude. Okay, so the magnitude will be magnitude of force modulus F will be, I'm just gonna mod 3.2 times 10 minus 13, mod the whole thing. So this will be 3.2 times 10 to minus 13, 4 square plus 5 square plus 2 square. Okay. 4 square plus 5 square plus 2 square, which is 45. So square 45 is 9 multiplied by 5. So this is 3. 3 multiplied by 3.2, 9.6 root 5 times 10 to the power minus 13. So I think I could just key in, maybe I just key in 3SF will do. So the answer that I got is 2.146 times 10 to the power minus 12, 2.15. It's in Newton, right? Newton. Okay, so that's the magnitude and this is the force. Okay, so that's how you do this question here proficiently.